Okay, okay. So, guys, welcome back. Here we are. Here we are. So, I would like us to continue from where we left off. We're doing vectors. Last time we did vectors in one dimension. So now it means that we're going to do vectors in two dimensions. Vectors in two dimensions, right? So vectors in two dimensions is not a hard thing to do. It's actually very simple. So we're just going to recap on what we did on vectors in one dimension, right? So in one dimension, we mentioned the difference between a scalar and a vector quantity, and I also explained how important direction is, right? So if you haven't watched the one that deals with vectors in one dimension, I'll leave out the link in the comment section and also in the description, right? So that you can watch the vector in one dimension, right? So vector in two dimension, when we're working with vectors in two dimension, mostly we like to work this on a what? On a Cartesian plane, right? So if you're doing science, obviously you're familiar with the Cartesian plane. Mostly Cartesian plane, we talk about it when we're dealing with math, right? So we know that our Cartesian plane is something. So Cartesian plane, we know that this is a Cartesian plane. It deals with the x and the y intercept, right? That is the Cartesian plane. Yeah. So this is the x and the y. And you know that this side our x is positive and this side our x is negative. That side our y is positive and here our y is negative. So we are going to deal with this on the what? On the Cartesian plane, right? And again, in math, you know that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, right? So this is how we are going to deal with this, right? So the main or the most important thing that drives us to do the vectors, to understand how vectors work. The most important aspect is finding the resultant vector. Finding the resultant. The resultant. And again, on the previous video, we explained what is the resultant vector. As I said, the resultant vector is the sum of two or more vectors acting on a single object. That is the resultant vector. It is the sum of two or more vectors acting on a single object. And also a resultant vector, we can also describe it as a single vector having the same effect as two or more vectors acting on a single object. So this is a single vector having the same effect as two or more vectors acting on a what? On a single object. Alright? So that is the definition of a resultant vector. So it means that we are going to add the vectors acting on a what? On a single object, right? So how can I make you understand this? So to understand this, I'll try by what? By doing an example on how we can find the resultant vector. So in the previous again, we're doing only vectors in one dimension. So vectors in one dimension, we're only adding the vectors that are going in the same plane. It's either left and right, left or right, left or right, left or right, or up and down, up and down, up and down, up and down, right? We didn't have the situation where we're having left and right and also up and down, right? So now vectors in two dimensions help us to understand how we can solve if we're having two-dimensional problem. Either the vectors acting up and down and also left and right. So that is the main important picture that will help us to understand this, right? So let's see how we can solve this. So don't forget that a vector is a physical quantity that has magnitude and direction. Magnitude and direction, right? So we are just going to try to find the magnitude and the direction of the what? Of the vectors in two dimensions. So it means that at this part, I'm going to divide this vector two dimension into two sections. The one that will deal with only finding the magnitude and the direction of what? Of the vectors. And on the second part, I'll deal with closed diagrams, and I also deal with components of vectors, right? So now we're just going to do how we can find the final resultant, the magnitude, and the direction, right? So suppose, let's say we're having this object, or rather let me just put it as a force, right? So let's say there are many forces that are acting on this object, right? So on this object we are having force 1 acting on this, which is 2 newtons to the right, and then F2, which is 3 newtons to the right, and then F3, which is 4 newtons upward, and then F4 being equals to 8 newtons upward, F5 being equals to 6 newtons downward, and lastly F6 being 1 newton, or let's rather say 2 newtons left. So we're having this situation like this. So these forces are acting on this object, right? So let's try to represent these forces that are acting on this object. Let's try to see, right? So it means that we are having F1, which is this, and we are also having F2, which is this. We are having F3 like this, and we are having F4 like this, and we are having F5. And also having F6, and they said find the magnitude and the direction that is of the resultant vector, right? So first thing first, we are going to deal with finding the resultant in one plane first, and then we find the resultant in another plane, and then from then I'll show you how to proceed, right? So as you can see, we are having the x component. So F1, F2, and F6 are in the what? X component, and as well as F3, F4, and F5 they are in the Y component, right? They are in the Y plane. So this is the Y plane, and this is the X plane, right? So first thing first, let's find the resultant in X, right? So before doing that, we choose the direction, right? So it means that if our right is positive, it means that our left is going to be negative. If our up is positive, it means that our down will be negative, something like that, right? That's what we discussed on the previous video, right? So it means that we are going to first deal with the x component, right? So our resultant in x component, it is equal to x, we are having this and that. So it will be f1 plus f2 plus f3, because it says we are going to add, right? So what is our force number 1? Our force number 1 is 2 newtons to the right, so it means that it is positive. So this will be positive 2 newtons. And then our F2 is 3 newtons to the right as well, right? So this will be positive 3 plus, and then our this is F6, right? And our F6 is what? 2 newtons to the left. So it means that our left is negative. So we're going to put negative 2, right? So our resultant in x end up being what? 2 plus 3 minus 2, which will be positive 3 newtons, right? But you know that this positive means what? Means right. So it means that our Rx will be 3 newtons to the right. So we find the resultant in x, right? So now it means that we can find the resultant in y. So how can we find our resultant in y? I don't know if this is one. So our resultant in y, how many forces are we having? We're having 1, 2, and 3, right? So it means that our resultant in y will be force number 3 plus force number 4 plus force number 5, right? And again we said our up is positive and then our down is negative, right? So this means that what is our force 3? Our force 3 is 4 newtons upward, which is positive. So this is 4 plus, and our F4 is 8 upward. So this will be plus 8, like that, right? And then our force 5 is 6 newtons downward. So this will be plus negative 6, right? So if we put everything all together, this our resultant in y now become what? Become 4 plus 8 minus 6, which will give us positive 6 newtons. So it means that it is upward, right? So now, let me just erase this. So it means that now we are left with the situation where we are having our resultant in x as 3 newtons to the right, and our resultant in y as what? As 6 newtons upward, right? So we are going to show that as a force diagram, right? So it means that I can erase this. We are having what matters, right? So what matters now is knowing that now the situation that we are having is this. We are having our resultant in y as 3 newtons, and we are having, our resultant in y is 6 newtons, and our resultant in x is 3 newtons, right? So it means that we can put this thing on a Cartesian plane, right? So this is the situation that we are having now. So we know that this is our Cartesian plane, so this is 6 newtons, and here it is 3 newtons, right? So our resultant, just imagine if two forces are pulling this. Obviously this will tend to go here in between, right? Because the force that will result in this one going that way and that way, it will coming in between. So this should be our final resultant. This should be our final resultant caused by our resultant in y and our resultant in x, right? So how can we find this resultant? Right, the magnitude of this resultant. So to find the magnitude of this resultant, it means that we can use theorem of Pythagoras, right? We can use theorem of Pythagoras to find this. How we can say our resultant squared is equal to the resultant in x squared plus the resultant in y squared. So we say this is theorem of Pythagoras, right? So our resultant squared becomes, now what is our resultant in x? Being 3 squared plus 6 squared. So this will give us 9 plus 36 resultant square. So it means that our resultant becomes 45. So our resultant final will be the square root of 45. What is our square root of 45? It will be 6,71 newtons, right? That is our final resultant here, right? But don't forget that when we're dealing with vectors, we need the what? The magnitude and the direction, right? So now, how do we find the direction, right? So first thing first, I'll find the direction of this. And I'll also help you how you can find the direction in different quadrants. Because if you can see, our solution is in the first quadrant, right? So it is a bit simple when you're working with the first quadrant, right? So if you when you're dealing with different quadrants, right? So don't forget that in science actually we don't have a negative magnitude, right? They are all positive, but that negative tells us the what? The direction, right? Okay. So how can we deal with this one? The way that we deal with this one is our angle is this, right? This is where our angle is. So we can say tan theta is equal to resultant in y over resultant in x, right? So it means that our theta simply becomes the second function of tan. And what is our ry? Resultant in y is 6 and our resultant in x is 3, right? So it means that our theta will finally become what? (43,43 degrees, right? So now I'm going to show you how you can place the whole answer as 1, right? We found our magnitude to be this, right? So we can say our resultant is equal to 6,71 Newton, right? We know that if we want to find the direction that is not left, right, up and down, it means that we can use the angle between the what? This, because don't forget that in math we say this is our 0 reference, right? As we go, the theta is increasing, right? The theta increases and here it is 90, 180, 270 and 360, right? So it means that the angle is this one, right? So we can say the resultant is equal to 6,71 Newton from the positive x-axis, right? So we count this angle from the positive x-axis. That's why we're saying this angle, sorry, we're supposed to include this angle here. So it's 6,71 Newton at 63,43 degrees from the positive x-axis, because that's where we are counting from. So it is 6,71 Newton at 63,43 degrees from the positive x-axis, right? So now I'm going to show you how you can do this if you're dealing with the second quadrant, third quadrant, or fourth quadrant, right? So I can erase this and then I'll show you, right? So it means that now we can work with any value of theta, right? Okay. Okay. So there are many ways on how they you can say your answer there, but the way that I prefer to use, I'll show you the way that I prefer it, right? And also it is a very simple one to understand, right? So as you said, this is our Cartesian plane, right? So it means that if our resultant is falling in the first quadrant, just like this, if our resultant is falling in the first quadrant, this is our theta, right? Let's say our resultant may be 5 newtons, right? And maybe our theta, so our resultant is equal to 5 newtons, and our theta is equal to 30, for example. So it means that this is our 30 degrees, right? So how can you put this all together? So this is the positive x-axis, right? So this is positive, negative, positive y, and negative y, right? So if you are having this equation in the first quadrant, so in the first quadrant, this is how you can write, and you can put everything all together, right? You can say our resultant is equal to 5 newtons at 30 degrees from the positive x, from the positive x-axis, right? So it means that we are just counting, because in mathematics, in trying to count our teachers anti-clockwise. So anti-clockwise is positive and clockwise is negative. So we can say it's 30 degrees from the positive, so it means that we are counting from the positive x-axis and we are having 30 degrees, right? So if maybe our situation was in the second quadrant and we happen to find our value of theta there, right? We said our theta is 30, right? So how can you put everything all together? In the what? In the second quadrant. So in the second quadrant, don't forget that in the second quadrant, this angle that is here, if you want to mention it, or if you want to put everything together, you can say our resultant is equal to 5 newtons at, so now just imagine what to say from the positive x-axis. So it means that from the positive axis, the angle that you can travel is this angle up to here, right? It is the whole angle that you can travel. So it means that we can say at 180 minus the theta, which is 30, and we say from the positive x-axis. It's more like we're using the reduction angle. So it means that we can find the answer there, 180 minus 30, which is 150 degrees, right? And if we're talking about the third quadrant now, if we're in the third quadrant, so already I'm sure you can see what's actually happening here, right? So in the third quadrant, we can say our resultant, so our third quadrant can be something like this, right? For theta is there. So in the third quadrant, this is what is happening. It means that we are going to travel this whole distance up until we get to this, right? So in the third quadrant, we can say our resultant is equal to 5 newtons at 180 plus 30. Because from here to here it is 180 already. And adding this angle, it is 180 plus 30, which is 210, right? And we say from the positive x-axis. And lastly, if we're talking about the fourth quadrant. If we're talking about the fourth quadrant, just know that it means that our situation will be like this, right? So I'll enter there. So in the fourth quadrant, there are two ways that you can say this, right? The first one, you can say our resultant is equal to 5 Newton at, so if you have traveled up to get to 360 degrees, and you can subtract theta, so you can say at 360 minus 8, which is how much? Which is 330 from a positive x-axis. Or rather we can say, as I explained that going that way it is adding, so going this way it is subtracting. So we can say also our resultant is equal to equals to 5 Newton at negative 30 degrees from a positive x-axis, something like that, right? So this is how we can explain how to find the resultant, right? So we learned how to find the resultant. It means that coming next, there's a video on how of solving finding the resultant vector, right? Yes. So in the next video, we'll be explaining how to resolve into components and close diagrams and the remaining of the stuff that is left, right? So see you on the next one. Thank you for being here.